Number 31. Determine the empirical formulas for the following compounds. Okay, so we've already talked much in depth of what an empirical formula is in the previous two questions. So if this is the first question that you're doing for empirical formulas and you have no clue, try to go back to number 29 and 30. So this one will kind of be more of a quickened version, but let's get down to it. So remember, guys, what is an empirical formula? An empirical formula is the simplified version, the most simplest form of a compound, all right? So how are you going to be simplifying, or how will you get the most simplified form of a compound? You will always divide your subscripts, all right? And remember what those subscripts are. The subscripts are the little numbers at the bottom of a compound. So for example, if I'm talking about H2O, there are 2 hydrogen. The subscript 2 represents for the hydrogen, and there's no subscript here for oxygen, so we assume that there's 1 oxygen here. So in this case, we have 2 hydrogen and 1 oxygen. Would I be able to simplify this formula? So you say to yourself, is there a number that I could simplify between a 2 and a 1 by division to get even, a less whole number? But there's really nothing that I could divide by. This is the simplest form. And especially if you see a 1 in your compound, it will automatically be the empirical formula, EF, I'll write for short. Okay, so I have A through E here, so let me just write this out. A, B, C, and D, and then we'll put E down below here. All right, so the first one, A, we want to find the empirical formula for caffeine, which is C8H10N4O2. Speaking of caffeine, I need some coffee. So I'm going to write it over here, C8H10N4O2. Now let's see. All of these formulas that they gave you are molecular formulas, right? Molecular formulas. These are the formulas that are given, and you can always transfer a molecular formula into its empirical formula by looking at the subscripts. So here we have 8 carbon, 10 hydrogen, 4 nitrogen, and 2 oxygen. Is there a number between 8, 10, 4, and 2 that you can divide by to get smaller numbers? Yeah, right? What number does the 8, the 10, the 4, and the 2 all have in common? They all have 2. So technically, you could divide each one of these by 2. That would be the highest number that you could divide by, because 2 divided by 2 will get you 1. And that would be like the purest form of an empirical formula if you have a 1 as your subscript. So if we do all that, this would turn into C4H5N2O. You could write the 1, but it's implied that if there's 1, you don't have to. So I'm going to just state it like that. And just as a double check, you have a 4, 5, 2, and a 1. There's really no number that's in common between those. So this would be your empirical formula. Box that off. That's the answer for A. Simple as that. B, fructose, C12H22O11. Fructose is a sugar, a simple sugar that is found in all your fruits. And it's also in that bad sugar, high fructose corn syrup, which I believe is 60% fructose and 40% glucose, but that's neither here nor there. So fructose is naturally found in fruits. But we still got to find the empirical formula. This is the molecular formula that they gave you. I'm looking between the 12, the 22, and the 11. Is there any number that's in common between these that I could simplify down? Not really, right? The 22 and the 11 have 11 in common, but now you're adding the 12 to the mix. So there's really no number that you can divide by all 3 of these numbers to get a simplified version. So if that's the case, this is also your empirical formula. If you can't break it down anymore, it automatically is the empirical formula. Letter C, hydrogen peroxide, H2O2. Let's see, that's the molecular formula that they gave us, H2O2. And now I look at the subscripts. I have 2 hydrogen and I have 2 oxygen. Is there a number that I can divide by both to get a simpler number? Yes, there is. I could divide both of them, the 2 and the 2. I could divide both by 2. And then it would turn into HO. Oh. But yeah, so you would just have 1 H and 1 oxygen. You can write the ones here, but it's implied that they are there. So box this off. That's the answer for C. So we got A, B, and C out of the way. D, glucose, C6H10N4O2. This is your other simple sugar. So this is like in your, like the table, actually no, not table sugar, because that's sucrose. But a component of sucrose is glucose. So C6H12O6. Look at those subscripts. We have a 6, a 12, and a 6. What's the highest number that you can divide to get this simplified? A 6, a 12, and a 6. I could divide each one of these by 6, because 6 divided by 6 is 1, and 12 divided by 6 will actually give you a whole number. So I could divide each one by 6. So this would turn into C1, you don't have to write the 1, H2O. Box that answer off. That's the empirical formula for glucose. And then last but not least, we have ascorbic acid, which is C6H8O6. So let me write that one down. C6H8O6. Look at those subscripts. I have a 6, an 8, and a 6. Is there any number between them that you can divide by that is the same number? What do these 3 numbers have in common? Well, I can't divide by 6, right? Because 8 divided by 6 is not a whole number. But they all have a 2 in common, right? If I divide each one by 2, you'll get whole numbers out. And that becomes C3, 6 divided by 2 is 3, H4O3. That is your empirical formula. And you know that you can't simplify it anymore because you now have a 3, a 4, and a 3. There's no number other than 1 that is that's in common for them, so you can't break it down anymore. All right, so this one was just taking molecular formulas and turning it into empirical formulas. Guys, I hope this helped. If it did, and you want to know, when our next batch of questions are coming out, click that subscribe button. It also gets the word out to other students like yourself who are trying to learn from the OpenStax textbooks. Thank you so much for that. I look forward to seeing you in number 22. I need to box this off or check it off. Okay, but with that being said, I'll see you in number 32. All right, bye-bye.